Hey everyone, and welcome. If you're diving into computer science, or you're just curious about what really makes your phone or laptop work, you are in the perfect spot. Today, we are pulling back the curtain on one of the most critical pieces of software ever created, the operating system. Let's get right into it and meet the computer's ultimate boss.
Okay, so picture this. You've just got your hands on a brand new top-of-the-line laptop. You're unboxing it, you plug it in, and you hit that power button for the very first time.
And everything's there, right? You've got the super fast processor, shiny new RAM, the keyboard, the mouse, all the physical parts are there just waiting to do some incredible things. But what if nothing happened? What if all those powerful parts just sat there confused?
I mean, what's going on? The CPU is basically saying, hey, I'm ready to calculate, but what should I calculate? The keyboard has no idea who to talk to. The whole thing is like an orchestra full of amazing musicians, but with no conductor. It's just silence. And that's exactly where our hero of the story comes in.
That hero, that conductor, that ultimate boss is the operating system, or the OS. It is the one crucial piece of software that breathes life into the machine. It's what turns a useless box of circuits and metal into the incredible tool we use every single day. So let's break down what this hero actually does.
The absolute easiest way to think about an OS is to see it as a manager. A really, really good one. It's the one telling the CPU what to work on next. It's deciding how much memory each app gets to use. It organizes all your photos and documents into files, and it makes sure your printer actually prints when you tell it to. It's the master coordinator doing all the heavy lifting in the background so you don't have to.
Okay, so now for the more textbook definition, the one you'll want for your exams. An operating system is a type of system software that acts as an interface, basically a bridge, between you, the human user, and the raw computer hardware. Just think about it. You click a nice friendly icon on your screen. The OS is the master translator that takes that simple click and turns it into the millions of ones and zeros the hardware can actually understand.
And this right here, this is the key takeaway. If you remember nothing else, remember this. The operating system has two main jobs that define its entire purpose. It's a resource manager, deciding who gets the memory, the CPU time, all of it. And it's a control program, making sure all your other programs run correctly and don't cause chaos. That's it. That's the core of what an OS is.
So, if the OS is a manager, what would its job description look like? What's on its to-do list every single second your computer is on? Let's take a look.
And wow, that is a long list. Its job includes managing every program that's running. We call those processes. It also has to handle the computer's memory, organize all the files, control every device plugged in, keep things secure, and, of course, give us a way to interact with the machine in the first place. So, yeah, it's busy. Let's zoom in on a couple of its most important duties. First up, process management. So let's say you have your browser, a music app, and maybe a game all open at once. The OS acts like a super fast traffic cop, basically saying, okay everyone, you'll all get a turn, but we have to do this in an orderly way. It takes every single one of those programs through a life cycle. First, it's new, just being created. Then it's ready, waiting in line. Then it gets its chance to be running on the CPU. Sometimes it goes into a waiting state, maybe for you to click something. And finally, when you close it, it's terminated.
Next on the list, memory management. You know, your computer's RAM is a limited space, like a shelf. The OS is the librarian who decides which books go where. So, for instance, if your laptop has 8 gigabytes of RAM in total, and the OS itself needs 2 of those just to run, well, that leaves you with exactly 6 gigabytes for everything else. The OS is constantly assigning that space and then cleaning it up when programs are done.
So how do we even give the OS our commands? Through the user interface. And there are really two main flavors. You've got the command line interface, or CLI. This is the text-based world of developers. Think of a blinking cursor in a terminal. It is incredibly powerful and precise. And then you have the graphical user interface, or GUI. This is what most of us use every day. The desktop, the icons, the windows. It's visual, it's intuitive, and it's way more user-friendly.
Now, not all operating systems are built the same. They're actually designed for very different kinds of jobs and different environments. So let's have a look at some of the different types you might come across. This slide shows a really cool evolution in computing. Way back in the day, we had batch systems. You'd literally feed the computer a batch of jobs on punch cards, and it would just chew through them one by one. There was zero interaction. It was all about making the machine as efficient as possible. But today, we mostly use time-sharing systems. The OS is so fast it gives every single program a tiny slice of CPU time. We're talking milliseconds. It happens so quickly that to us, it feels like everything is running at the same time. That's the magic trick behind multitasking.
But what happens when even a millisecond of delay could be a disaster? That's when you need a real-time operating system, or an RTOS. For these systems, it's not enough to be fast. They have to be predictably fast. They guarantee that a task will be done within a super strict deadline. And as you can see, you find them in some seriously high-stakes places: missile systems, life support machines, and precision robots. In these jobs, timing isn't just important, it's everything.
Okay, so we've seen what an OS does from the outside. But what about its internal blueprint? How are these unbelievably complex pieces of software actually put together? Let's take a quick peek under the hood.
A really common way to design an OS is with a layered structure. You can think of it like building a house. At the very bottom, you have the foundation, the hardware itself. Then you build a layer on top of that for CPU scheduling. Then a layer for memory management, and so on, all the way up to the roof, which is the user interface. And the one big rule is, each layer can only talk to the layer directly above it or directly below it.
And this whole layered idea perfectly shows off a classic trade-off you see all the time in computer science: making things simple versus making them fast. The big advantage here is that it's way easier to build and fix. If something breaks in the memory management layer, well, you know exactly where to look. The disadvantage? A command might have to pass through all those layers, which can add a tiny bit of delay, making it just a little bit slower than other designs.
All right, we have covered a ton of ground. So before we wrap up, let's boil it all down into a final toolkit. These are the absolute key concepts you should take away from all this. Here it is, your OS cheat sheet. First, the two main OS roles. It's the friendly interface for you and the tough resource manager for the hardware. Its core functions are the big four: managing processes, memory, files, and devices. The key types you need to know are the old-school batch systems, the time-sharing systems we use today, and the critical real-time systems. For structure, remember the layered approach builds the OS in levels. And finally, don't forget key concepts like the 5 process states and that tiny time quantum that makes multitasking possible. If you've got these down, you have a fantastic foundation. So, let's end with this thought. Right now, the operating system is this invisible, powerful force that runs our entire digital world. But our world is changing, right? We've got AI, quantum computing, and billions of smart devices all coming online. So the big question is, what new, wild, and complex things will the operating system of tomorrow have to manage? What's the next big challenge for the computer's ultimate boss?